Hi there. Once we covered the three-dimensional coordinate systems, it is just to clarify uh, about the z equal 3. If we look to the zy plane, looking from this side, we will see that this is a line that extends from minus to plus infinity in the y-axis. But if we look in the plane in this direction, we can see that in the z equals 3 extends over the y-axis in plus minus infinity. So this z equals 3 is a plane that goes in all directions from the origin at the height of 3 according to the z-axis. Okay, let's move on to how to calculate the distance between 2 points in a three-dimensional space. This is one of the most important things to keep in mind because many of your future calculations in relation to forces, newtons, uh, magnitudes of physical variables like current, motion will be calculated in base of this formula. So as an introduction, if you remember your basic geometry course at high school, in the Pythagorean theorem showed us that we have a right angle triangle like this one, and let's say that this is the opposite angle, opposite side, B is the adjacent, and C is the hypotenuse. So if these lengths are known, there is a way to know or to find the length of the hypotenuse, and this is by means of this formula, c squared equals a squared plus b squared. And this is the Pythagorean theorem. So we are going to use the same principle to calculate the distance between 2 points in a three-dimensional space. So this formula plus others related to trigonometry are going to be used in an extensive way during your course of multivariable calculus. I draw this little um, rectangular prism, and I draw here the point P1. The point P1, the coordinates for this P1 is x1, y sub 1, and z sub 1. Let's say this is the point P1. And we have another point P2, and this P2, the coordinates for this P2 is x sub 2, y sub 2, and z sub 2. So we're going to apply this Pythagorean theorem to calculate the distance between P1 and P2. And from here, we are going to demonstrate the formula for the distance between 2 points in a three-dimensional space. The first thing, I draw this little rectangular prism just to show that we have projections of two triangles here. So I draw here this little point A, and we have this little point B, and this is P1. So let's say this is triangle number 1, and we have another triangle here. The hypotenuse for this one is P1 and P2. We have the side P2B and P1B. So this is triangle number 2, and both triangles are right angle triangles. So let's write that, and let's take note of this. The first triangle is going to be if we want to calculate the hypotenuse of this is going to be uh, P sub 1b square, because we want to know the distance for what? For this hypotenuse of the triangle number one, equals P1a, which is P1a square plus um, AB square. AB is this side over here. P1A is this side over here. And we want to know the distance between P1 and B. So this is going to be the notation to know the length of a line between 2 points. So for many of your future calculations, we're going to add some little arrow on the top of this, just to indicate that this is a vector or a line from two given points. For triangle number two, if we do the same, we can see that the point P1, P2 square, which is the point, the distance from here to here, equals P1, P2B square plus P1B square. We add these little arrows to indicate that this is vectors. And now we have the Pythagorean theorem for these two triangles, triangle 1 and triangle 2. So what's the reason why I'm showing these two triangles? Okay, this is because we are going to demonstrate the formula for the distance from these two triangles here. And the reason to draw this geometric figure is to let you see that we have a projection of point P1 from the x-axis from here to here that forms the triangle number one, and we have a projection of the length, which is from point A to point B as the triangle number one, and we have a projection from point P2 down to the point B. So if we combine these two formulas together, we can see, if we take a closer look to our triangles, that P1, P2 equals A P1 squared plus A B squared plus P2B squared. Okay, if you take a closer look, you can see and verify that AP1 is the distance from here to here. AB is the distance from here to here. And P2B is the distance from here to here. Okay, so from this first expression, we can rearrange this like this. So this is equal to the x value 2 minus x1 squared plus this over here is the y2 minus y1 squared plus this, the third one, is z2 minus z1. And that equals P1, P2 square. So this one is the first part of the formula for the distance. Okay, and to get back the values from the squared, if we take the square root of that, we can come up with the following simplified formula. So the distance between P1 and P2 equals x sub 2 minus x sub 1 squared plus y2 minus y1 squared plus z2 minus z1 squared, and we're going to take the square root of that. And this is the formula for any distance from 2 points in a three-dimensional space. Please take note of this formula. We are going to use it a lot during all this course and all of future courses, especially when we were working with physics. You will apply this calculation a lot because this is the formula for the distance, and this notation between these two vertical bars are the magnitude or the modulus of any vector, and you are going to see that represented in this way. So if you saw a vector between these two vertical lines, that's represent the module. In this case, we are using the same to represent the length of the line between P1 and P2. Okay, if we now consider a sphere, we have this sphere in a three-dimensional space, and the center point of the sphere is the point C, which has the coordinates h, k, L, and the point P right in the outer surface of the sphere, and the coordinates for this point P is x, y, z. So if we want to find the distance between the point C and point P, we can now get that if we name this line R squared equals x minus h squared plus y minus k squared plus z minus L squared. So this is the same formula that we use for this very first problem, and I hope this is clear for all of you. And this is our first class on how to calculate or how to find the distance between 2 points in any three-dimensional space applying the Pythagorean theorem.